Welcome to Math Tutorials. In this video, we are solving every question of exercise 1.1 of Chapter 1, Relations and Functions, from the NCERT Mathematics textbook for Class 12, Part 1. Exercise 1.1 has 16 questions, all about one idea, testing whether a relation is reflexive, symmetric, and transitive, and recognizing equivalence relations. Here are all 16 questions. Let's begin with question 1. Question 1. Let's read it. We must determine whether each of the following relations is reflexive, symmetric, and transitive. Part 1. The relation 3x minus y equals 0 on the set of numbers from 1 to 14. Part 2. Y equals x plus 5. With x less than 4, on the natural numbers. Part 3, y is divisible by x, on the numbers 1 to 6. And Part 4, x minus y is an integer, on the set of all integers. Part 1, the condition 3x minus y equals 0 just says y is 3 times x. Reflexive, test 1 with itself. 3 times 1 minus 1 is 2, not 0, not reflexive. Symmetric, 1 relates to 3, but 3 times 3 minus 1 is 8, so 3 does not relate back. Not symmetric. Transitive, 1 relates to 3 and 3 relates to 9, but 3 times 1 minus 9 is not 0. Not transitive. Part 2, with x below 4, the whole relation is just 3 pairs. No element pairs with itself, so it is not reflexive. 1 goes to 6, but 6 never goes back. Not symmetric. A chain would need a pair starting at 6, 7, or 8, impossible with x below 4. Transitive trivially. Part 3, y divisible by x. Every number divides itself, reflexive. 1 divides 2, but 2 does not divide 1, not symmetric. If x divides y and y divides z, then x divides z. Transitive. Part 4, x minus y an integer. Any integer minus itself is 0, reflexive. If x minus y is an integer, so is its negative, symmetric. And two integer differences add to an integer difference, transitive and equivalence relation. Part 5 of question 1. The relations now live on the set of human beings in a town at a particular time. Relation A, x and y work at the same place. Relation B, x and y live in the same locality. Relation C, x is exactly 7 centimeters taller than y. Relation D, x is the wife of y. And relation E, x is the father of y. Relation A, same workplace. You work where you work, reflexive. If x works with y, then y works with x, symmetric. And sharing a workplace chains through a common colleague, transitive and equivalence relation. Relation B, same locality. The identical 3 checks apply. Equivalence again. Relation C, nobody is 7 centimeters taller than themselves, not reflexive. If x is 7 above y, then y is 7 below x, not symmetric. And chaining 2 such pairs makes x 14 above z, not 7, not transitive. Relation D, no one is their own wife, and the wife of x's husband relation reverses to husband, not wife, so neither reflexive nor symmetric. 2 wife of pairs can never chain, the middle person cannot be wife and husband at once. Transitive, trivially. Relation E, chaining father of pairs makes x the grandfather of z. Not transitive, and not reflexive or symmetric either. Question 2, let's read it. The relation r on the real numbers relates it to b when it is less than or equal to b squared. We must show that r is neither reflexive, nor symmetric, nor transitive. Reflexive, try a equal to 1/2. 1/2 is bigger than its square, 1/4, not reflexive. Symmetric, 1 is at most 2 squared, but 2 is not at most 1 squared, not symmetric. Transitive, 3 is at most 4 and 2 is at most 2.25, but 3 is not at most 2.25. The chain breaks, not transitive. Question 3. On the set 1 to 6, the relation relates it to b when b equals a plus 1. We must check whether it is reflexive, symmetric, or transitive. The relation is each number paired with the next one. 1 with 1 would need 1 equals 2, false, not reflexive. 1 relates to 2, but 2 relating back to 1 would need 1 equals 3, not symmetric. 1 relates to 2 and 2 relates to 3, but 1 relating to 3 would need 3 equals 2, not transitive. Question 4. The relation on the reals relates it to b when it is less than or equal to b. We must show it is reflexive and transitive, but not symmetric. Every real number is less than or equal to itself, reflexive. If O is at most b and b is at most c, then O is at most c, transitive. But 1 is at most 2 while 2 is not at most 1, not symmetric. Question 5. This time A relates to b when A is at most b cubed. Again, we must check all three properties: reflexive, symmetric, transitive. Reflexive, 1/2 is bigger than its own cube, 1/8, not reflexive. Symmetric, 1 is at most 8, but 2 is not at most 1, not symmetric. Transitive, 3 is at most 3/2 cubed, and 3/2 is at most 6/5 cubed, but 3 is not at most 6/5 cubed, which is about 1.73, not transitive. Question 6. On the set 1, 2, 3, the relation contains exactly two pairs, 1, 2, and 2, 1. We must show it is symmetric, but neither reflexive nor transitive. Each pair's reverse is also present, that is symmetry. But 1, 1 is missing, not reflexive. And 1 relates to 2, 2 relates back to 1, so transitivity demands 1 relates to 1, which it does not transitive. Question 7. A is the set of all books in a college library. Two books are related when they have the same number of pages. We must show this is an equivalence relation. Every book has its own page count, reflexive. Equal page counts are equal in either order, symmetric. And if X matches Y and Y matches Z, all three counts are equal. Transitive, so R is an equivalence relation. Question 8. On the set 1 to 5, A relates to B when the absolute difference of A and B is even. First, we must show this is an equivalence relation. Then, 1, 3, and 5 are all related to each other. 2 and 4 are related to each other. But the two families never mix. The key observation: an even difference means both numbers have the same parity. A minus O is 0, which is even, reflexive. The absolute difference ignores order, symmetric. Same parity chains through a middle element, transitive, and equivalence relation. 1, 3, and 5 are all odd, so every difference among them is even, all related. 2 and 4 are both even, so they are related to each other too. But an odd minus an even is odd. The two families never mix. Question 9. The set is the integers from 0 to 12. Relation 1 relates it to B when their difference is a multiple of 4. Relation 2, when it equals B. For each one, we must show it is an equivalence relation, and find the set of all elements related to 1. Relation 1, a minus A is 0, which is 4 times 0, reflexive. The absolute difference is order blind, symmetric. And two multiples of 4 add to a multiple of 4, transitive, an equivalence relation. Related to 1. Distances 0, 4, 8, or 12 from 1 inside the set, that is 1, 5, and 9. Relation 2, plane equality, is reflexive, symmetric, and transitive on the nose. Equivalence. And the only element equal to 1 is 1 itself. Question 10. We must give an example of a relation for each of 5 combinations of properties: symmetric only, transitive only, reflexive and symmetric, reflexive and transitive, and symmetric and transitive. Part 1 on 1, 2, 3, take just the two pairs 1, 2 and 2, 1. Symmetric by construction. 1, 1 is missing, so not reflexive, and the chain 1 to 2 to 1 has no 1, 1, so not transitive either. Part 2 strict less than. Chains survive, so it is transitive. But nothing is less than itself, and the order never reverses. Part 3 within distance 1. Reflexive and symmetric, since distance is order blind and everything is near itself. But 1 is near 2 and 2 is near 3, while 1 is not near 3. Not transitive. Part 4, less than or equal, reflexive and transitive, but not symmetric, exactly as we proved in question 4. Part 5, on 1, 2, 3, relate 1 and 2 to each other and themselves, leaving 3 out. 3, 3 is missing, so it is not reflexive. But inside the pair, everything is symmetric and every chain closes. Question 11. A is the set of points in a plane, and P relates to Q when both are the same distance from the origin. We must show R is an equivalence relation, and that the class of any point P is the circle through P centered at the origin. Write d of P for the distance from the origin. Every point matches its own distance. Reflexive. Equal distances are equal in either order. Symmetric. And equality chains through a middle point. Transitive, an equivalence relation. Now fix P at distance R. The points related to P are exactly those at distance R. And that set is the circle of radius R centered at the origin, the circle through P. Question 12. Triangles are related when they are similar. After proving it is an equivalence relation, we take 3 right triangles, sides 3, 4, 5, sides 5, 12, 13, and sides 6, 8, 10, and ask which are related. Every triangle is similar to itself, reflexive. Similarity is order blind, symmetric. And matching angles carry through a middle triangle, transitive, an equivalence relation. Now compare T1 and T3. The side ratios 3 to 6, 4 to 8, and 5 to 10 all equal 1/2. Related. T2's sides are in proportion with neither triangle. It stands alone. Question 13. Polygons are related when they have the same number of sides. We prove it is an equivalence relation. Then find every polygon related to the right triangle T with sides 3, 4, and 5. Side count is a number, and the relation is equality of that number, so all 3 properties come for free. The triangle T has 3 sides, so its class is every polygon with 3 sides, all triangles. The lengths 3, 4, 5 play no role. Question 14. L is the set of all lines in the xy plane related when parallel. We prove it is an equivalence relation. Then find the set of all lines related to y equals 2x plus 4. Every line is parallel to itself, reflexive. Parallelism is order blind, symmetric. 2 lines parallel to a third are parallel to each other. Transitive, an equivalence relation. Parallel means equal slope, and our line has slope 2. So the related lines are all lines of slope 2, y equals 2x plus c for every real c. Question 15. R is given as an explicit list of 7 pairs on the set 1 to 4. We must determine whether R is reflexive, symmetric, and transitive. All 4 diagonal pairs are in the list. Reflexive. 1, 2 is present but 2, 1 is not symmetric. Check the chains. 1 to 3 then 3 to 2 needs 1, 2 present. Every other chain closes the same way, transitive. Question 16, the last one. A relates to B when A equals B minus 2 with B greater than 6. Which of the pairs 2, 4, 3, 8, 6, 8, and 8, 7 belongs to R? Check 2, 4, B is 4 which is not above 6. Rejected. Check 3, 8, B is fine but 3 is not 8 minus 2. Rejected. Check 6, 8. 6 equals 8 minus 2, and 8 is above 6. Both conditions hold this pair is in R. And 8, 7 fails, since 8 is not 7 minus 2. So only the pair 6, 8 belongs to R. That completes all 16 questions of exercise 1.1. In the next video, we will take up exercise 1.2 on 1.1 and onto functions. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.